Good evening, everybody. Welcome to the US vBrownbag. This evening, we're going to talk about what's new in VSAN 6.2 with Jase McCarty. He is at Jase McCarty. If you want to, please get in on the conversation, either at vBrownbag or hashtag vBrownbag. I'll be monitoring the Twitter feeds. Or if you're live in here, feel free to ask a question. I'm Chris Williams at Mistwire, and Jase McCarty at Jase McCarty, obviously at jasemccarty.com. Jase, I'm going to cut over the presentation to you.
Okay.
And
let me know when you can see my gray VMware. Let's see, there it is.
There you go. I see your screen.
Right. And let's see. Is that showing up? Let's see. I'll try to hide that. All right, so I think we're going to do a bunch of slides tonight. No. So again, my name is Jase McCarty, and I work for VMware in the Storage and Availability Business Unit. And we're kind of the group that handles virtual SAN, virtual volumes, also vSphere replication, as well as Site Recovery Manager. Right, so we're kind of to some degree the storage side of VMware, if you will. We don't necessarily focus a lot on the core storage stuff. A lot of the vSphere core team will do that. We're really kind of focused in the SDS space, if you will. So, and I had talked to Frapp a couple months ago about doing this brown bag specific to kind of what's new as far as Virtual SAN 6.2. So please feel free as I'm going through the content. I've got a couple slides. I've actually got, if you notice down here at the bottom, I've got a couple different environments. So yes, I'm going to do some live demos, and hopefully they won't fail on me, but you never can tell over a VPN when you live 20 minutes from where they film Swamp People. But with that being said, if we're going along and there's a question of some type, hey, tell me about this, I want more detail, that type of thing, please feel free to put it in the Q&A box or the comments box. Chris will ping me, and we will go from there. We'll try to go a little bit deeper. And if we need to go off the rails, if we need to dig a little deeper, that type of thing, within the confines of the time that we have, I'm very happy to do that. So with that being said, I'll go ahead and kind of dive in. And for anybody who's not familiar with Virtual SAN, and again, I don't want to make this all about slides and slides and slides, but anybody who's not familiar with Virtual SAN, really what it is it's VMware software-defined storage play, if you will, or if you include it with vCenter and also SXI, you can really look at it as our HyperConverged software stack, right? So we take multiple hosts between 2 and up to 64 in a single cluster. We can manage multiple clusters by in a single vCenter across multi vCenters, that type of thing. But we take a local storage. It's comprised of either solid-state devices for our cache tier and capacity devices made of either solid-state or traditional spinning drive. We put this all together in one big aggregate pool, and we call it the vSAN data store. Right? The important thing to keep in mind around the vSAN data store or vSAN itself is it's an object store as opposed to a traditional block or file, file type data store, whether it be NFS or iSCSI or fiber channel based presented storage. It's an object file or an object storage system. Now, it's built into the kernel. We don't really have to run any virtual storage appliances or anything like that. But one of the things to me that really brings the most value when it comes to Virtual SAN is the fact that and I was a customer for 15 years, so I was the guy that they would always come to and, hey, we need a LUN, or hey, we need a mount, or whatnot. And it was always a pain in the tail when it came to juggling, well, I've got this performance characteristic on these drives and this particular tray, and I remember the days when I had to spread things across trays, for redundancy and protection and whatnot, right? All that, all those spreadsheets upon spreadsheets upon spreadsheets. And with Virtual SAN, we're really all about storage policies, and I'm going to show those in just a minute within the interface. But what I mean specifically about storage policies is I can go and I can say, I want this VM configured in this fashion, or just this component of the VM configured in this fashion. So if I want, let's say I have a SQL VM, and I choose to have a different stripe width for, let's say, for instance, the D drive, which I've got my SQL database on. If I want to change the level of performance of that particular VMDK while it's running, I can do that, right? Whereas, the old-fashioned way of doing things, we would have to go and call the storage guy. Hey, look, it looks like RAID 5 is not really doing it for me. Have you got some drives available? Maybe we can try a RAID 10 config, and then once you get it set up, then I'll move it over to it, right? Well, we don't have to do that anymore. And that's one of the things that I like the most about Virtual SAN. So let me jump around and basically say this isn't really new, but I will say in 6.0 we did it.
One real quick, Jase. Can you put that up into presentation mode? Some people are having a hard time squinting at it.
Oh, sure. Let's see. Get that out of the way and try that. Come on. Okay. Thank you. All right. Is that a little bit better?
Yes, they're saying thank you.
Sweet. All right. Sorry about that.
No worries.
So, important thing to keep in mind is we do support all flash and hybrid configs. All flash being capacity tier residing on solid state devices. Hybrid configuration, the capacity tier is on traditional spinning drives, and that we call it hybrid because it's a mix of solid state and traditional. If you look at the numbers that we've got listed here, this 100,000 IOPS per host, that was actually on a particular configuration where we had 2 disk groups on those hosts. I think it was like an Intel cluster where we had 64 nodes getting about 6.4 million IOPS in the total cluster, and each node had 2 disk groups. Do the math, it comes out to about 105,000 IOPS per host, on average. Important thing to keep in mind when it comes to that is, that's only 2 disk groups. We could go up to 5 disk groups. So you could conceivably, depending on the workload and the profile, you could conceivably go significantly higher, right? All right, now I'm going to zip through these slides kind of quick because I don't want to spend a lot of time on the slides. I want to make sure we get some hands-on as far as that goes. But 6.0 was introduced about a year ago. That's when we introduced all flash. 6.1 was really my first product launch at VMware. I've been there. April was about a year for me. Before that, I worked for EMC previous to VMware, and then I was a customer for 15 years before that. But with 6.1, we introduced stretch clusters. We introduced 2-node, which is essentially a stretch cluster config in a 1+1+1 type of configuration. I'll show you my home lab in a minute. That's actually a 2-node. And then we've added some like a health check UI, which I'll show as well. And then in 6.2, which we released back in March of this year, we added deduplication and compression. We added erasure coding, RAID 5 and RAID 6 support, software checksums, and so on. I'm not going to read them all off. But important thing I want to keep in mind and mention is from March of 2014 to March of 2016, in 2 years, we've added a significant number of features. And customers keep asking, and we keep adding additional features, right, as far as that goes. So deduplication and compression is something that people have asked for quite a while. This is one of our new features. And if you notice at the very top, it says all flash only, right? And this, it says here, this will be called space efficiency. This, as well as erasure coding, effectively is called space efficiency. But important thing to keep in mind when it comes to deduplication and compression, if you notice the illustration, I've got 3 nodes here, a single VM residing on that particular data storage running on the first host. Deduplication and compression is actually a cluster-wide setting. So it doesn't necessarily tie into the normal storage policy management, if you will, in comparison. Now let me flip over where my mouse is here. Whoops. And see if it'll let me come up with all right, so like this is a cluster that I've got here in my house, right, that I'm in the process of configuring. I just blew it away, and I'm in the process of blowing it away. But notice here that I've got deduplication and compression enabled. It's a cluster level setting, so it's not really specific to any particular VM, and it's not really specific to any particular policy, right? It's either always on for the cluster or it's always off for the cluster. There's no here or there. Now, if you notice, I've got a couple hosts here. I've got a witness running. These are actually running on an NFS data store because I didn't want to have to recreate them as I'm building this cluster, if you will, right? But I literally go in. This is how easy it is to configure Virtual SAN. Well, let me back up first, and let me look at the hardware on one of these hosts, right? And these are just some little Sandy Bridge systems I've had for about 5 years, but I put some certified hardware in. And the process of doing that, look at my storage devices. Take just a second. I apologize. They don't pay me enough for killer gear or anything like that. But
wait,
they don't.
You're not Webster? Ah, outrageous.
No. All right. So if you notice here, I've got, this is just like this is an old, I'll call it consumer grade solid state device that I'm literally running ESXi off of, right? There are no special requirements for that particular, there's an error, okay. This is just a consumer-based drive. I'm not really going to be writing any data to it. This is just my local install of ESXi. Now, I do have a Micron P420M PCIe solid-state device that Micron was gracious enough to lend to me for a short time, and then I've got two additional solid-state devices that I'm going to be using for capacity. Now, with that being said, I've got my onboard storage controller here, and then I've got this is actually it's an Avago LSI 9361-8i. Now, the interesting thing is this card is not certified for an all-flash configuration per our HCL, but it's actually the same exact chipset as the Dell H730, which is certified for an all-flash. So I'm going to be a little risky here when it comes to that. But if you notice, I've got two devices running on that particular controller. And then from that, I've got the Micron solid-state device, right? So when I go to set up vSAN, I mean, it's really literally this easy. This is new. When we first had vSAN up to literally about version 6.1, it wasn't quite this easy, right? So I'm going to say I want to add disks manually. I want to enable deduplication and compression, and in this particular case, I'm going to do a two-host configure or two-node cluster, right? And then it checks to ensure that. And I did a presentation. I want to say beginning of May, and Michael Haig, who's in storage and availability as well. He's one of the product marketing guys. He asked me, what's the one thing that you always forget to do when you set up your vSAN environment, anytime you set up a demo or whatnot? And I personally always forget my networking, always, right? The nice thing about this is this will actually go and say, okay, these hosts are already configured from a networking perspective, and you can add them very easily, right? So I've already got them set up. All right, now I will say I'm running a development build, so I may or may not run into some issues. It looks like I'm going to. But what we would do is we would add disks here, and then in the process of adding disks, we would then add a witness, right? And then I go and I add my cache tier, and I add my capacity tier, and I hit finish. Now I'll have to go back and look at my disks again in a moment under disk management. But important thing I wanted to mention, though, is specifically around deduplication and compression is enabled at the cluster level. Now, if we come back over here, let me get this out of the way.
Quick question.
Uh-huh.
Actually, several people have asked the same question, and I don't know if you're going to be getting to it eventually. And if you are, we'll just table it until you get to it.
Go ahead and ask. No.
But it's can vSAN coexist with vVols? How does vSAN interact with vVols? I don't know if yeah.
Well, so that's actually a very good question, right? So let me kind of go back to my environment here, right? If I look at my data stores in my home lab here, and I've got a little Synology 1813 Plus is what it is. If you'll notice, I've got some data stores, localhost 1, localhost 2. NFS is actually my Synology device, and then my vSAN data store. Now, if you look at the different hosts that I have the witness down here, and I've got host 1 and 2. These VMs right here are actually running on my NFS data store. Now, where this is all kind of important is vSAN doesn't really care if you consume other storage types. So with that being said, if you want to, let's say you wanted to run, Unity from EMC with their new vVols capability there. If you want to run, NetApp filers with their vVols capability, you want to run SolidFire, whatnot. Anything that supports vVols as well as as vSAN or NFS or traditional block storage. You can all use them all together, right? I will mention that when it comes to vVols and when it comes to traditional storage, those, I'll say storage tiers, if you will, not really tiers, but devices, those storage targets is probably a better way of saying it, can really be used across any clusters, right? Whereas vSAN is a per cluster resource, right? So with that being said, if I wanted to, let's say, have vVols and use vVols across 2 independent clusters, then I could do that. With vSAN, though, I'm only consuming those resources within that cluster. Okay, so that's kind of a differentiation. Now, I will show one thing. Let me just make sure I've got my disks up and running here. And they may or may not be. Okay, there we go. So they're there. Right, I'll see that I've got my capacity devices. But where it's kind of important, and again, the thing I was talking about that I like the most when it comes to vSAN is the fact that, and these are VM storage policies that happen to be on my system because I don't have vVols installed or anything with vVols installed. I can have policies that are specific to vVols. Like I could say a new storage policy, and I'll say just temp, right? And then I'll come over here and I'll pick a rule set, and that rule set would be vVols if I've got something vVol compatible. Right, so I can go and I can add a rule, number of failures or whatever, right, as far as that goes. The important thing to keep in mind when it comes to SPBM, storage policy-based management, is I can go and I can assign a policy to a VM, and if I've got vSAN storage as well as vVol storage that both satisfy the requirements, then I can easily pick either one of those, right? So let me. No, the webcam is not working, Tim. Sorry about that. Let me show an example of this. I was just looking at Twitter, right? Right. So like this VM right here, control, right? So I can go and I can say, I can migrate this VM from my NFS-based storage. I want to change the storage only. This will probably take a while because I've only got 1 gig. I don't have anything significantly fast. I mean, I've got a teeny little 10 gig switch for the hosts, but unfortunately it's not tied into the Synology because it doesn't support it. So I can come over here and I can say, okay, I want to protect from one failure, which is the most I can do in a 2-node config, and I want to give it a stripe width of 1, right? So I go and I do that, and it says, oh, okay, well, only this vSAN data store is compatible. If I had a vVol data store that was also compatible with those policies, then I could do that as well, right? So at that point, I just hit next, and it'll go and say, all right, I'll storage vMotion, and I'll move it over, right? And let's see, I don't know if I want to look at my health and performance. Maybe I will. Come back and look at my monitor here. And I'll go ahead and say that I'm probably going to get some errors here because, yeah, haven't configured the performance service yet, and I think from cleaning up a little bit earlier, I've got a couple objects that are inaccessible, but we'll get it started rebuilding those. So that's one of the really important things when it comes to vSAN is the fact that it's going to be rebuilding. There we go. Home lab, live demo. Anyway, but the policies, right? Policies for vVols, policies for vSAN, and whatnot. It gives me a lot of choice. Now, if you'll notice, without going deep into Erasure or into deduplication and compression, because I want to make sure we get a good bit of the meat, I'll go into Erasure coding now. It's important to keep in mind that when it comes to Erasure coding, if I go and I create a new policy, and I click on my VM storage policies here, if I go and say, well, no, I don't want to change one. I want to create a new one. So I'll create a new one, and I'll say, I'll call it RAID 5, right? Which is kind of, maybe it's appropriate enough to call it that. I'm going to say vSAN. I'm going to add a rule, and I want to choose my failure tolerance method. Notice I have a couple options here, RAID 1 or RAID 5/6 Erasure coding. Okay, it's important to keep in mind that on 2-node configurations, on stretch cluster configurations, and on hybrid configurations, mirroring is the only option today. Okay, and the reason that is because, let me go back over to this right over here. If we look at the configuration of the cluster, if I go and I look at my fault domains and stretch cluster, right, I've essentially got one fault domain here, one fault domain here, and then I've got my witness handling the metadata, right, for those objects. So if I look at this control VM, the one that I was migrating over, and I'm not sure if it's done or not, it's in the process of doing that, but if I go and look at that and I look at the policies for that particular VM, once it moves over, we may have to come back. Oh, there it is. Right. It's not going to show it to me there. Maybe I need to go to cluster, and I need to go to monitor, virtual disks. There we go. Come on. It hadn't done it because it hasn't moved yet. But what will happen is this will show me where that particular object is as far as placement goes. In other words, I'm going to have one copy on one host, I'll have another copy on another host, and then the metadata that basically acts as the tiebreaker from a clustering perspective is going to reside out on the witness. Now, I can change other things, like I can change my stripe width, I can change, disable checksums, I can do in a hybrid config, I can do an object space reservation, those types of things, where I can literally custom tune different pieces of a VM. If I had multiple hard disks here, multiple VMDKs, then I could independently choose a different policy for each. Like if I were to take my VCSA, which is again running on the NFS side right now, and move it over, I could literally go, and there's not going to be any policies here, but I could tie a different policy to each one of these, right? So I can literally say, okay, right now it's data store default. I want to do FTT1, stripe FTT0, stripe width of 1. I wouldn't do that because it only gives you one copy, but let's say you want to do a stripe width of 2 here or whatnot, right? You can independently tune, and where that brings a lot of value to me is, like I was saying before, I don't have to call a storage guy or me be the guy wearing all the hats doing storage also and carve up another LUN just to meet the individual requirements of one piece of a workload. I gave a session at VMworld last year along with SanDisk where we had done some performance testing on I want to say it was an Oracle workload on a 4-node all-flash configuration. And this was before we had erasure coding, before we had deduplication and compression, because it was 6.1. But we found that if we changed the stripe width of a particular VM, if all we did was change the stripe width of one particular, actually VMDK of that VM, we could adjust the performance, right? And essentially where that table or those tables that we were hitting in our performance testing, if we wanted to make a stripe width of 8, we didn't really see any more performance than we did with a stripe width of 6. Versus a stripe width of 4, we saw a degradation in performance. So 6 was kind of our happy spot, right, if you will. But I can do that on the fly. I can make the change, I can apply the policy, and then once it meets that policy and becomes compliant with that policy, I can go and I can look at it again and say, okay, what's the performance of it? How does it look, right? So let's see if controls. Okay, so it's come up. Any questions so far?
A couple.
Okay.
First off, is what does it mean? What does it mean by erasure coding?
Okay. So erasure coding is essentially erasure coding is actually a broad spectrum, if you will, of I'll say data reduction techniques, if you will. RAID 5 could be considered a type of erasure coding. RAID 6 could be considered a type of erasure coding. The way that we do protection is we have, as I mentioned before, in the policies, I mentioned that we had, let me just go back to it really quickly. I mentioned that we had a failure tolerance method, and I'm just going to zip through here so we can see them. A failure tolerance method of either mirroring or erasure coding. There we go. So mirroring or erasure coding. So in a hybrid or stretch cluster config, again, mirroring is our default. Erasure coding gives us the capability of really spreading it out a little bit differently, our data out a little differently. Now, the important thing to keep in mind with mirroring is I have a copy here, I have a copy there, and that's it, right? There's no, additional overhead specific to how we're laying the data out. Whereas erasure coding like RAID 5, I typically have to have, I mean, RAID 5 itself can be like a 2+1 or a 3+1 or 4+1 or whatnot with one, essentially a parity bit, if you will. The way we do it in Virtual SAN with RAID 5 is we spread it across 4 objects. So we say a 3+1, if you will, distribution. We call that an FTT or we call that RAID 5/FTT1 erasure coding. And what that essentially means is if we were to lose one of those components, then the other 3 components could put everything back together. RAID 6 would be if we want a failure tolerate of 2. So if we want to be able to lose 2 complete objects, in the process of doing that, we would need to have, say, RAID 6 requires 6 hosts, RAID 5 requires 4 hosts, mirroring requires, the formula is actually 2n+1. And what that basically means is if we want to protect from 1 failure, then we have 2 copies, and require 3 hosts. If we want to protect from 2 failures, then we have 3 copies, and we have to have at least 5 hosts, and so on.
Okay.
I hope that kind of clears that up.
Yep, it sure does. And the second question was, can a VM have disks with VSAN policies and disks with vVol policies?
Absolutely. Absolutely. You can independently tie policies to different objects. So you can have one VMDK, let's say you're running, let's say you've got some type of array-based replication or something, and you want to be able to replicate, data disks, but OS disks you want to run on vSAN, you could absolutely split those apart.
Cool.
At the same time, if you wanted to have a VM running on vSAN that had a requirement for an RDM, we don't support physical RDMs in general on vSAN.
Right.
And if you wanted to have an RDM pointing at a traditional storage and you want to be able to run the rest on vSAN, you could absolutely do that. All right, so here's kind of erasure coding. This is, again, RAID 5, kind of a distribution of where the data is laid. Now, important thing to keep in mind when it comes to mirroring, if I have a completely full 100 gig VMDK and I do mirroring FTT1, I'm going to take up 200 gigs. Right? With RAID 5, that 100 gig VM is only going to take up 133 gigs. So erasure coding is very beneficial when it comes to guaranteed storage capacity savings, right? So RAID 5 essentially gives us 50% more usable space than we do with mirroring with 1 failure to tolerate. If we've got 2 failures to tolerate, we essentially get 100% more capacity to use. So where an FTT of 2 mirroring would require the first 100, another 100, and a third 100, that's 300, and a RAID 6 FTT2 type configuration, then it gets to the point where now we only need 150 gigs as opposed to 300 gigs. Okay? And that's guaranteed. That's not, it depends on your workload. Or no, it's none of that, right? Erasure coding is a guaranteed capacity savings because of the way that we write. Now, I'm not going to say that it comes without a little additional overhead. It does, because using erasure coding, as you go to lay data out, every write actually becomes a read and modify as opposed to just a write. Mirroring, we just write to any and all VMDKs because they're whole objects wherever they reside across all of our different devices within the vSAN data store. But erasure coding is going to say, okay, well, I've got to read what's there, I've got to modify what's there, and take into account the calculations for my erasure coding with my parity, right? So there is a little additional overhead. We're not seeing anything significant. We typically say about up to 10% CPU utilization with vSAN in general, with mirroring, and we're seeing between 2 and 4% or so additional CPU requirements when erasure coding and deduplication and compression are all enabled at the same time. So in the grand scheme of things, it's not really significant. As I was saying, we typically say 10% CPU in general, but we see some customers that only utilize 2% of their CPU, or 4% of their CPU, or 8, or something like that. So it's really not significant. And the great thing about vSAN is vSAN is going to scale, from a CPU and memory requirement perspective appropriately. If I have more cache devices, I'll take up a little bit more RAM. If I have less cache devices, less disk groups, then I'm not going to take up as much. We don't ever run into a situation where we have to, turn any nerd knobs, if you will, to try to add more resources to vSAN. It's going to intelligently work across the spectrum, given the hardware that's in the in the system, right? All right. Let's see. And I don't want to go over any marketing slides. So we did add quality of service. I would really kind of call this really IOPS limits, right? Important thing to keep in mind is if you have that one noisy neighbor application, when I was in financial, I used to work for Equifax. It wasn't uncommon for one particular customer or various customers would do end of month reports. Well, end of month, after a couple times that it happened and they ran these really poorly written queries against their databases, we would see performance, a lot of, I'm not going to say performance degradation, but a lot more utilization than we had seen in the past. Whereas we could use something like our quality of service feature, if you will, to be able to limit and not let them use any more IOPS than a given amount that we that let's say they subscribe to, or that particular department has paid for within a organizational budget or whatnot, right? Any questions so far, Chris?
Oh yeah, we're getting peppered.
No, go ahead.
Tom is asking, what has been the most unusual case for vSAN so far?
Unusual?
Yeah, I'm not sure. If there's something cool, I'm not sure.
Well, I don't know of anything unusual per se, but I mentioned before I'm a really big fan of 2-node, and from an HCI perspective, most HCI vendors, really it's either 1 node or 3 nodes. 1 node doesn't give you a lot of redundancy. 2 nodes gives you some redundancy at a smaller footprint. 3 nodes obviously gives you a little bit more availability, but at additional cost from a hardware licensing perspective. I've seen vSAN deployed in ships, in submarines, on oil derricks.
Really?
I've seen some hardened. I'm not going to say Pelican cases, but I've seen some hardened, deployments for various environments where, I think it's pretty interesting that if we design it right and set it up right, then we can definitely, meet that. Now, I'm not going to say we're not the only solution out there that will work in a 2-node config. I mean, at one point we had the old, VSA, which would do 2-node, and I think we still have some customers out there that are still under support using that in like large retail environments and that type of thing. But I think 2-node, is probably going to pick up, in the next 6 months or a year.
Tom just said oil rigs answers my questions.
Yeah, I mean, if you think about from the perspective of if I can put either a lot of capacity or a lot of flash, enable deduplication and compression. Again, erasure coding is not available on 2-node, but if I can go and I can put a lot of capacity in a very, very small frame, and I'll be honest with you, the hosts that I have here at the house don't take up any. I mean, there's no heat as far as that goes. I mean, very low power, very, very tight, small space. I think it's great. I mean, 2-node is probably my favorite way to deploy vSAN. Now, it's not to say there aren't some operational challenges when it comes to 2-node, when it comes to upgrades and different things like that, because you don't necessarily have the additional redundancy. You typically have to be in a degraded mode as you're going through upgrades, right? Because you've only got two failure domains, if you will, or fault domains, if you will. All right. More questions?
One last one. What is the memory overhead for this?
Well, memory overhead typically for vSAN itself is sorry about that. My wife is in the middle of nowhere with no cell service and is trying to call me. Anyway, typical overhead for vSAN as far as a memory, I covered CPU a minute ago, but memory starts out at about 3 gigs of RAM. And we've got a formula. There's a KB article on it. It's really easy to find. If you Google vSAN memory requirements, it'll literally spell it out. That KB article will tell you literally how much it takes. I've seen some cases where, if you're in a fully configured 64-node, all 5 disk groups are in use. I've seen 32 gigs of RAM, but
Mm-hmm.
we average between 6 and maybe 12 gigs of RAM.
Oh, that's not bad.
And if you think about hosts today, I mean, again, it all depends on the disk group configuration, the size of the cache devices.
Mm-hmm.
But I mean, if you look at hosts today, I mean, it's so easy to get a host with 128 gigs of RAM. They're not expensive, right? In the grand scheme of things, so it doesn't take up a lot. I'll mention that we do take some of that RAM. A new feature in 6.2, and I've got it listed here, is called Client Cache. What Client Cache does is it works kind of like CBRC or the View Storage Accelerator did for virtual desktops.
Mm-hmm.
But we take 0.4% of the RAM up to a gig, and we allocate that as a local read cache. Now, it's important, I didn't mention this before specifically, but a VM could be running on host number 1, but yet the data could be on host number 2 and host number 3 in a 3-node, right? And that client cache, what that does is that reserves, a gig of local RAM as a read cache. So, acceleration as far as that goes. But there's really no affinity of a VM to the data. A VM could be completely somewhere else, from the VM, as long as it's within that same cluster.
Gotcha.
Something that I'm kind of proud of is the next one that you see here is called Sparse Swap. We were having some conversations internally around January, and we're talking about the way that the swap file is actually created, and keep in mind that VSAN is an object store, right? So as we go and create that swap file, let's say I have a VM with 4 gigs of RAM allocated to it, and I don't do any reservations, then I'm going to make a vSwap file that's 4 gigs. Well, it's typically a thin vSwap file, but it has the capacity of getting very large. Now, in VSAN by default, we reserve that space. And everything's thin on VSAN, but we actually apply a policy, a hard-coded policy, with an object space reservation of 100, right, or 100%. What that basically means is that 4 gig vSwap file, even though it's not taking up any actual capacity in my VSAN data store, we're reserving that space, right? So if I've got a large, a VM that I'm not doing any reservations on, I've just taken capacity away.
Mm-hmm.
And I had this conversation with Christos and a couple of other guys, and we were kind of just emails back and forth, and I said, why are we doing this? And they're like, well, what do you mean? I'm like, well, wouldn't somebody who's familiar with nerd knobs and is watching their capacity, wouldn't it be awesome if we could take away that 100% object space reservation and make it require nothing, right? Basically not pre-allocate that space or protect that space. I mean, don't get me wrong, if you run out of capacity, your swap doesn't have space to write to, if you overcommit, that VM's going to fail. And that's just the nature of things. But if you're one of those guys like me, that gets in and fools with the nerd knobs and whatnot, it's really watching the environment, then you could really watch this space, right? You could really use it. Like, I spun up 500 VMs on a little 4-node cluster that I have, with 4 gigs of RAM each, and it used 4 terabytes of capacity. 2 terabytes for the vSwap files themselves, and then 2 terabytes for the mirror, right? Because we by default on swap files do an STT of 1, right? So at that point I took up 4 terabytes of space doing nothing. And the funny part is I only have like 6 terabytes of space on that cluster, right? So it kind of put me in a bit of a bind. But then I upgraded to 6.2, made the change, and it took up 3.6 terabyte or 3.6 gigabytes of capacity, knowing that I'm not overcommitting any of those VMs from a memory perspective. So that's one of my favorite little features that we added in 6.2. I actually do on my site, which you mentioned earlier, have a PowerShell script that'll actually go in. You can point it at a cluster, and it'll turn that off on all the hosts.
Oh, nice.
Make that setting change. Yeah, a couple of them. Actually, one to turn it off, one to turn it on, and one just to look and see what it is. So something else I'll mention that I really like, and I'm going to show this in just a second with 6.2, is now we've got advanced reporting from a capacity monitoring perspective, and then also the fact that from a performance service, and I may have to go enable it to be able to do this, but I can literally go and look at the IOPS, the utilization from a cluster, from a host, from a disk group, from a storage device, and from a virtual disk perspective. I can look at the IOPS, I can look at outstanding I/O, I can get very granular. And this is built into the product, right? It's not anything that I have to add VROPs or anything like that on, to make it happen. Let's see if I can find a cluster that. No, that's not a good one. I don't even know what cluster this is. Wish there was a way for me to. Oh, look at that! I'm connected twice to the same cluster. Wish there was some way I could change this color. I'm gonna have to get onto a mod and see if you can come up with a way of changing colors in the client. But I can literally go in and I can say under monitor I can look at performance and I can drill down. And it may not be on because you have to enable it, I may not have it enabled. But for like what's going on right now, I can literally go in and I can look at a particular time frame, and I can go and I can say, oh, come on. I'm probably going to go enable it. Come on, home lab. All right, so if I, and keep in mind, I'm running dev code here. I'm not actually running GA code, so no. All right. And I come over here to my health and performance. Okay, so it's enabled. It's enabled. All right. All right, so if I go and look at my performance, and it'll take it a second. This is not the fastest, so I can look at my IOPS, my throughput, my latency. This is at the VSAN level, right? I'm seeing about 2,000 IOPS on the cluster right now. Really not anything. I've only got one VM on it, but I can go to that was at the cluster level. I can literally go to the host itself, and I can go back to monitor, back to performance, and I can look at performance from a VM perspective. I can look at the back end. I can look at the disk groups on a host. In a particular configuration where I have multiple independent disk groups, again, remember I can have up to 5. I can look at the performance for that particular disk group, or I can even drill down to an individual capacity device or cache device on that particular node, right? So if I have one problematic capacity device, let's say I need a firmware upgrade or something like that, I can literally, where's the mouse? There we go. I can literally go in and drill down to each one of these, right, and see what the performance is, right? And I can have completely different performance characteristics, across different capacity devices, depending on how data lands, right? I could have a stripe width of 2, and I could take that VMDK, that control VM, and it could reside on 2 completely different capacity devices. I could do a stripe width of 4 or whatnot. We actually do up to 12 on a stripe width, right? So it's, again, all policy. Let's see if this is going to show me. Yeah, here we go. So if I look at my physical displacement, I should see, and it'll say RAID 1, right? Because I've got one on host 2, one on host 1, and then I've got my witness little metadata sitting over here. Now, I can go and I can check and ensure the profile compliance. It checked it. It's good. Literally, I can come over here and I can say VM policy. I want to change the policy to a stripe width of 2, and I'll just do it all. Well, I can do it to all of them. It's important to keep in mind, though, the home space. This is where your VMX file and your NVRAM and all those other pieces are. They all reside in the VM home, but it's important to remember that it's actually not spread across multiple stripes. It really only maintains a single stripe width, even though I'm applying the policy to it. All right. So I'll go in and do that, and it'll take just a second. We immediately see that, hey, well, it's still compliant. But now our data disk is not compliant. So if you notice here, what it's actually doing in this case is it's taking this particular component, and it's making a copy, putting it on 2 different capacity devices on the opposite node. It's taking this one, and it's doing 2 independent capacity devices on this particular node. Right, so it's literally making a copy and migrating it to that as we speak. Once it's done, then we'll only see effectively 5 components there. We'll see 2 components on one host, 2 components on another host, and then the witness component off on the witness or witness appliance, if you will. Right? That to me is what's awesome. That I don't have to call a storage admin and say, "Give me a new LUN. Give me a new LUN that's RAID 10 or give me a LUN that's, RAID 5 or, whatever, RAID 6 for cheap and deep, whatever. I can custom tailor that on my own, right, as far as that goes. Let's see. The health check plugin, maybe this will work for me now that I don't have so many errors, right, in my home lab. And, oh, that's where I wanted to go. I was in the right spot. Okay. So, like, I can also see that here, right? I can also see my components, right, as far as that goes. And as they're being migrated, right, I can also go and look at my health here. And I'll probably have some errors. Okay. So I do have a hardware compatibility error. This is specific to the Micron drives because we're not really checking storage devices, only controllers as far as that goes. But if I were just using this with some like locally attached SAS or SATA drives, then it would show up all green as far as that goes. But here I can look at my network, and I can see that all my hosts have a VMK NIC present. They should show up at the bottom here in a second. I've got matching multicast settings, and these are anemic hosts, so I apologize. Matching subnets and whatnot, right, as far as that goes. Checks my MTU, show me pings. Hey, everything's pinging okay. Everybody's talking to everybody fine. All these things that are typically built into a traditional storage array, we're exposing this from a distributed computing perspective, so it makes it easier for the storage admin or virtualization admin to have very, very granular visibility into what's going on, right? I can look at my data. I look at the health of objects. I don't have much. I just have the one host, but this 5 objects is the VMDKs themselves as well as the home space, right, and the swap file. I can go and I can look at the cluster. I can see that, hey, I've got proper deduplication consistency across all hosts. All the hosts have the right disk format version and whatnot, right? So a lot of granularity. And then from a 2-node and stretch cluster config, I can easily see that I've got everything properly configured. I've got good latency, right? Really, really cool stuff. Now, I'm not going to go into proactive test because I know it's going to bomb on this particular system that I have, but I can go and I can do a storage performance test. This actually ought to work pretty well. My multicast I'm having some issues with, so it's not going to show a good response. But I can proactively go and check the configuration of the cluster, right, to ensure that everything's properly working. Now, there's going to be one instance of this for each cluster. So if I have multiple clusters, like in this environment right here, then I would have multiple health reports, if you will. All right, with that being said, I need to delete this guy. I meant to do that earlier. And we're kind of running late on time. How are we on questions?
I have 4.
Oh wow! Okay.
But I don't want to. I mean, if you're on a roll, I don't want to bug you.
Oh no, go ahead.
Okay.
I want to make sure we get them.
Well, here's an easy one. There's some Yahoo named C Bunch on here asking what's a LUN. So we're gonna just skip right past that one. Dinesh is asking how many node configuration is the most common for a VSAN deployment? You said 64 was the max. But what's
so 64 is the max, but if you look at the perspective of our Evo Rail appliance that we had in the past and the current VX Rail appliances, they start out at 4, right? And if you think about it, 4 is kind of a good place to start. One of the challenges that you run into with a 3-node configuration is, 3-node works well, don't get me wrong, but let's say you're going through a maintenance action, you're upgrading a host. You're in the process of upgrading vSphere on a particular, ESXi on a particular host. And if we have an FTT of 1, now don't think 2-node and stretch cluster type configs where we have a witness, but think about having data on host 1, data on host 2, and let's say a witness component on host 3, that type of thing. If I need to bring host 1 offline because I'm doing maintenance, I don't really have anywhere to put that data. Right, so I've effectively at that point got to run in a you could say a reduced availability mode, if you will, as you're performing that upgrade, right? In a 4-node config, that's kind of what I would look at as a hot rebuild type type scenario, right? Where if I really wanted to be 100% certain, then I could go and I could completely evacuate all the data off the node that I'm working on, and then I've still got that 3-node availability as far as that goes. So I would assume that's one of the reasons they started off with 4 nodes, right? As far as that goes. But I've seen 4 nodes, I've seen 8 nodes, I've seen 12, I've seen 16, I've seen 10. It's really dependent on the workload. Some people will actually go and do a very small, 4-node or 6-node specific to, they want to isolate a particular workload from a licensing perspective, right? That type of thing. So it's really kind of, your own use case. The challenge that I run into most often is, you hear people quite often will say, well, we need to be able to support X amount of nodes. Well, the entire time I was a customer, as well as the entire time I've been a vendor, I don't think I've ever really seen a large percentage of any customers going higher than 32 nodes. I think 32 is kind of a, I'm not going to say a ceiling per se, but it's kind of it's kind of just a norm as far as the largest that I've seen.
Okay.
Right, as far as that goes.
Do you see any customers deploying vSAN for uses requiring remote replication?
I apologize. Hold on one sec.
Sure.
Yes. Call.
Is Cody bugging you again?
Back. Yeah. Dumb. It never fails either. So, but anyway, what was the question specifically?
Do you see any customers deploying vSAN for use cases requiring remote replication?
I don't know what you mean specifically about remote replication. I mean, do you mean like using vSphere replication, or are you?
I think he's talking about either just as a source or as a target for remote replication using something else like vSphere replication or Zerto or something like that.
So we do see that a lot in I would say in our robo deployments, if you will. I mean, I've seen it in some of the large mirrored data centers. There's always the question when it comes to availability. Do I want to use, let's say, vSAN on 2 different large data centers and then use vSphere replication in conjunction with Site Recovery Manager? You could absolutely do that.
Okay.
You could also potentially, like I was talking with a customer here in Louisiana, that they were looking at deploying 2-node clusters, or 4-node clusters in some remote grocery stores, and they said they didn't do a lot of, didn't have a lot of performance necessarily requirements during the day, but yet in the evening, there were some things that they did specific to, some I'm not going to say adjudication, but bringing in all the receipts of the day and all the inventory and all those different things. They could in that particular case, change a policy, change performance, or like a cache reservation or whatnot in our hybrid configs, and then at that point they could tie that into replication, right? It really all depends on the use case. But we do, in pretty much every vSphere license, you do get vSphere replication, for free. In 6.1, we introduced the fact that, or now support the fact that, if you're replicating from a vSAN data store to a target vSAN data store with vSphere replication, for free, we can, up to a certain number of VMs, we can meet an RPO of 5 minutes, or RTO of 5 minutes, right? If you're going from vSAN to a traditional data store or traditional data store vSAN or whatnot, then 15 minutes is kind of that ceiling, right, as far as that goes. If you went the VX Rail route, they do include, I'll say, a similar product, which has a little bit different capabilities from a synchronous and asynchronous perspective, called Recover Point for Virtual Machines. But you could very easily do that with vSphere replication, RP for VMs, or some of the other per VM replications, I'll say, technologies out there. The important thing to keep in mind, though, is we don't do any type of currently, any type of replication based on the vSAN data store itself, right? It's all per VM.
Right.
And one of the reasons that I kind of like the fact that we tie it into vSphere replication is it works with all of our other products, right? Specifically, if we're using, traditional arrays, or file systems or even vSAN. We can use vSphere replication with all of them. It works very well with SRM. So more questions?
No, that was the last one.
Oh, good. I'm caught up.
Yep.
Okay. Trying to think what else I wanted to show you guys, and I'm sure Dinesh is probably going to give me hell the next time I talk to him. I will say, and this is, of course, a marketing slide, right? And I think we're right at the end of our time, but and there's a ton of stuff that I really didn't get to cover. I kind of just covered the highlights of what's new. But if you want to play with vSAN and you don't want to have to spin anything up, if you don't want to have to invest any money in gear like I have here in the home lab, you can go try our hands-on lab. And let me actually put that full screen again, right? You can try our hands-on lab. And that doesn't cost you anything. You can do it from any kind of browser, right? Whether it be on an iPad or Android device or on your desktop, laptop, whatever. If you're a vMug Advantage member, or by default, VirtualSAN is free for the first 60 days, right? So the standard trial licensing. But you can get a 6-month eval as a vMug Advantage member, I think for free. So it basically extend that by 4 months. Or you can get an eval experience for $200, and that basically gives it to you for a year for your home lab. And I don't know how many licenses that is.
It's 6.
Yeah. 6 CPU licenses, right? So with that being said, also, if you really think vSAN is something that would work well in your environment, and keep in mind, we initially positioned vSAN as a as a tier 2 test and dev, whatnot type solution from a very conservative stance early on back in the 5.5 days. But what we found over the past 2 years is customers are running more and more, and in fact, I've got a slide specific to this. Customers are running more and more workloads on vSAN, business critical apps, right? SQL, Oracle, Exchange, different things like that, BCAs. We see a lot of VDI. VDI, if you have the Horizon Advanced Suite or Enterprise Suite, they're tied in from a licensing perspective. So it's not an additional cost from a vSAN license perspective. I really like, I mentioned Robo, how I'm smitten, with lack of a better term, specific to Robo and 2Note. But I really like the fact of management, like a management pod. I mean, how many people have ever had, a virtualized domain controller, virtualized, DNS servers, whatever else, and they're running on the storage that they're in the process of doing an upgrade to, right? You could get in a chicken and an egg situation. So we're seeing a lot of people go in and deploy management clusters, whether it be a single VxRail appliance or something like that, just to put their core, AD and DNS and some of the other really essential services on top of an isolated vSAN instance. And then going a little bit further, DMZ. I spent 24 years in the military, with 19 of that in communications, and we had a lot of secure zones, right? Specific to air-gapped security zones where we don't have to worry about. Yeah, I'm smitten. I see your tweet. But if you think about it, I don't have to go and buy this huge, this array or this scaled down array that gives me a subset of features. VirtualSAN, whether it's a 2-node or 3-node or 4-node, that I can fit in 2U depending on the deployment form factor. I mean, I can have an isolated security zone complete with enough capabilities and resources that I don't have to worry about, coming up with some special way of deploying everything with a traditional array. One of the things I really think is great about vSAN is the simple fact that we can scale down just as easily as we can scale up. And a lot of people don't think about that. I mean, you go and you look at a large array and you say, well, I'm going to run 500 desktops, and you buy this array, and then 50 people actually use it. Well, then you've wasted a ton of money. Or you buy a little array, and then you say, we're only going to run about 100 desktops, and then everybody wants some. Next thing you know, you're trying to shoehorn 500 into a frame that'll only accommodate 100. So vSAN is really, really awesome in the fact that it scales up and it scales down. A lot of people don't realize that. But the last thing I wanted to mention is if you think vSAN might be a good fit, or you're interested, you're in the process of going through let's say you're looking at some new hardware or whatnot. if you take a vSAN assessment, and all it really does is we install a VIB on your hosts, and they take the take the performance metrics of writing and reading data essentially, and we collect all this. It takes about a week, and you can run it longer if you'd like, but it's free, doesn't cost anything. But we can take those numbers and then specifically say, okay, given your particular workload, this is what you would expect as far as a requirement of a comparable vSAN environment. Or if you expect to grow by 50% in the next 6 months or the next year, then you would need this much more, that type of thing. And because vSAN scales linearly from a performance perspective, it's kind of that building block approach, right? Where, if I know that today I can support 400 desktops or 800 desktops on 4 nodes or whatever, depending on the config or type of type of worker, if you will. I know that if I need to add this much more, then I just add this node, add 2 nodes, add 4 nodes, whatever, right? So it makes it very, very easy. All right, I think I've gone through the bulk of the spiel. I'm trying to think what else. I hope you guys were impressed that my lab didn't completely die. Right?
Dude, that's far better than any lab I've been able to launch.
Well, let's see if my let's see if my VM. Let's go back and look at the policy and see if my VM is compliant. Right? Let me check it. It should say compliant. Now it's compliant. If I go look at that VM, let me close that so I can see. Oh, come on. And it's obviously it doesn't want to show it. Look at that. Just as soon as I say something about the lab, it decides not to. It's gonna fail. I know it is. Me and my dev code. Sorry. Here we go. And refresh. I should see my control VM, and notice now that it's spread across multiple on the fly, right? I didn't have to do anything special. And I didn't call a storage admin and give me a new LUN. Right?
Cool.
All right.
I think
I will say feel free to reach out to me on Twitter, just Jase McCarty. I will say I'll also be at the Minneapolis VMUG UserCon on Tuesday, as well as HP Discover in Las Vegas on Wednesday and Thursday. So if you're around, please feel free to come by, say hello, and ask me any more stump the chump type questions. Happy to do my best to answer.
Cool. Well, Jase, thank you very much for your time this evening. We certainly do appreciate it.
Oh, honey badger. All right. Okay.
You'll have to go through and check out all the other ones too. I was having a good time.
I can only imagine. I can only imagine. Okay, so cool. Am I still sharing? How do I stop sharing?
I'm going to stop the recording now.